In this media, you will learn about some types of arc welding. Metal arc welding is the usual arc welding process in which the electric arc is produced between the consumable electrode and base material to weld them. Shielding metal arc welding uses a consumable flux-coated electrode which is also used as the filler material. It protects the weld area from oxidation by producing carbon dioxide gas when the electrode is consumed during the welding process. In this welding process, the maximum working temperature is 3000 degrees Celsius. This simplest and oldest arc welding process is limited to ferrous metals and requires lower operator skill. Plasma arc welding is similar to tungsten inert gas welding, but it uses a plasma gas for providing constricted arc. This welding also uses a non-consumable tungsten electrode and a separate shielding gas to protect the welding pool. In excess, the plasma gas, that is, the ionized gas, is forced through a copper nozzle to produce the pilot arc when it contacts with the electrode. The arc produced at higher temperature is thinner, longer, and more focused, and it is transferred to the metal pieces to be joined. Plasma arc welding is useful for obtaining deeper and narrower welds and provides increased welding speed. Submerged arc welding is the one in which the granular flux is used to shield the weld pool from atmosphere. In this welding process, the granular flux is fed on the workpiece followed by the consumable electrode driven by an automatic drive roll. When the electrode moves into the granular flux, arc is initiated and this arc is invisible because it is submerged beneath the granular flux. Flux forms a thick layer that covers the molten zone and prevents the spatter and sparks. It also slows the cooling rate of molten pool and it can be recovered, treated, and reused. It is widely used for high-speed steel plate and sheet welding, but it is obviously limited to welding in a horizontal position. It requires skilled operator and provides high quality of the weld. Carbon arc welding is the oldest and the first arc welding process ever developed. Electric arc is struck between the non-consumable carbon electrode, usually graphite, and the weld piece. Filler material and shielding gases are also used, and the working temperature of this welding process is more than 3000 degrees Celsius. TIG welding is used in place of carbon arc welding applications, though carbon arc welding is a low-cost and simple welding process. Atomic hydrogen welding uses two non-consumable tungsten electrodes to produce the electric arc. Hydrogen gas stream is passed on the electric arc so that the hydrogen molecules dissociate into hydrogen atoms at this arc temperature. These hydrogen atoms absorb the heat energy of electric arc. When the arc is passed on the workpiece, the hydrogen atoms again join together and release the tremendous amount of absorbed heat energy. The temperature range is 3400 to 4000 degrees Celsius during the process, and the coalescence of the two metal pieces takes place at this temperature. Here, the hydrogen gas also plays the role of shielding gas to protect the weld area from atmospheric contaminants. Flux cord arc welding is similar to shielded metal arc welding, but the electrode used in flux cord arc welding is less brittle than that of shielded metal arc welding. In flux cord arc welding, the electrode is a continuously fed, consumable tubular wire which has interior flux or a mix of flux and metal powder. Either emissive fluxes or non-emissive fluxes are filled in the electrode core. Emissive fluxes produce the shielding gas to surround the weld area, whereas external shielding gas is used when non-emissive fluxes are used. flux cored arc welding provides higher deposition rate and it is suitable for welding ferrous materials of higher thickness. Electroslag welding is a single-pass process carried out in only vertical or near-vertical position. It is used in weld steel plates of thickness between 25 to 300 millimeters, 1 inch to 12 inch. Initially, flux material is filled in the gap between the two vertically positioned metal pieces. An electric arc is struck between the electrode and the workpiece. The arc heat melts the flux to form the molten slag. Electric current passing through this molten slag allows it to continue its liquid stage. A water-cooled copper dam is used to enclose the space to prevent the molten slag from running off. When the molten slag reaches the temperature of 1930 degrees Celsius, the consumable electrode and metal edges get melted. Now the metal droplets are deposited into the weld pool, thereby joining the metal pieces. Now you have learned about the different types of arc welding.
वीडियोस बनाने हैं, फिल्मोरा है ना।